All right, so this first activity here in quadratic functions everywhere is called profit selling sweatshirts. An equation can be written for a business to determine how much profit they will make. For an example, your business began selling sweatshirts at a cost of $10. The first year you sold 1,000. Great first year. You decided to raise the selling price by $5 and found the total number sold decreased by 100 sweatshirts. See the table below. It costs $10 to produce each sweatshirt. Something I want to point out here, the table and the graph are not of the same information. The table here has to do with the number of sweatshirts sold at each price. The chart over here, this is the profit of sweatshirts sold. So they are not the same thing. So don't try to take the ordered pairs from the chart and match those up to the graph, because the graph is of something different. The graph has to do with the profit and the selling price. The chart has to do with the number sold at the selling price. So they are two different sets of data for the same situation. Now, before we go any further, to remind ourselves of standard form versus vertex form. We started out the unit in standard form, then we transitioned lately to vertex form, and most of what we're doing today is back in standard form. Standard form is that f of x equals ax squared plus bx plus c. Vertex form is that f of x equals a times the quantity x minus h squared plus k. So we need to remember we have these two different forms of the equation we've been working on in this unit. Most of what we're going to see in this particular activity is back to the standard form. So then it says, using some algebra, you determine the equation to represent the relationship between the selling price S and the profit F of S, assuming you continue the trend of raising the price by $5 and selling 100 fewer, is F of S equals negative 20S squared plus 1400S minus 12,000. So this is the equation that you determine based on the data we have that models the above function. Okay, that's the graph of that equation. So they're asking us a series of questions here about the graph. What is f of 10 and what does this mean in the context of the problem? What is f of 20 and what does this mean in the context of the problem? What is the meaning of the vertex of the graph? How many sweatshirts had to be sold to make a profit of 10,500? What is the domain and range of the function in the context of this problem? And if you had a choice, what price would you set for the sweatshirts and why? You'll notice a lot of these questions talk about in context of the problem because this is a real life situation. In real life situations, we have to understand what these points of the graph mean. And in a real life situation, we don't always use all the points on the graph of the function because in real life, I can't sell for a negative price. I can have a negative profit. Something can cost more than I make, but I can't sell it for a negative $10. So we have to know in context of this problem what it means. So the first question here says, what is f of 10 and what does it mean in the context of this problem? Well, right here is f of 10. what does that mean in the context of this problem? And again, we're talking about the graph side. What is the value when I sell it for $10? How much profit am I making? That's really what this question is asking. When I'm selling for $10, how much profit am I making? None. It's at 0. So f of 10 equals 0. But what does it mean in context of what does it mean for 0? And that's it. The f of 10 means selling for $10 is getting us 0 profit. That's what the f of 10 is telling us. So they are making 0 profit. They are selling the sweatshirts for what it costs to make them. So that's what at $10 selling, we have 0 profit. So f of 10 equals 0. The next one, they say, what is f of 20 and what does this mean in context of the problem? So here's 20. So this is f of 20. If I take out my ruler, and I line it up with that 20, I can see where my profit is. So when I sell it for $20, how much profit per sweatshirt am I making? Because remember, it costs $10 to make. So if I'm selling it for $20, how much profit am I making per sweatshirt? $10. So f of 20 equals 8,000. They are selling for $10 more, giving them $10 profit per sweatshirt. So by raising the price up to $20, now I'm making $10 per sweatshirt. So that gives me a profit of 8,000. That's what that f of 20 equals 8,000. That's telling me what the amount of profit that I'm making is. So what is the meaning of the vertex of the graph? So they give us this vertex on the graph here. What does it mean, 35, 12,500? What is the meaning of that? It's the most I can make. It's the maximum amount of money that can be made. So the meaning, so at the vertex, they are making a maximum profit of $12,500 and selling the sweatshirt for $35. So if I sell the sweatshirts for anything over $35, I'm not going to make as much money. 35, that's the maximum amount of money that I can make based on this function. Question 4 says, how many sweatshirts had to be sold to make a profit of $10,500? So now we've got to work backwards. We know what profit we're working with, and this is a little tougher because we got to guesstimate. Halfway between would be 11,000. So then I've got to take half of that to kind of guesstimate where my 10,500 would be. So if I go across, I hit my graph in two different points here. And if I see where those points lead me to my price, so how much did I sell them for? So what is this value right here? 25. What would be the other value? 45. So does it make a difference if I sell 25 or 45? No, I'm going to make the same amount of money. So looking at the first one, it said how many sweatshirts. Now, that means I have to go to the other chart. At $25, how many sweatshirts am I selling? 700. So that's where the table, why you have to look at both of those. So 700 sweatshirts selling at $25 each will give them a profit of $10,500. And then by symmetry, a selling price of $45 will also yield a profit of $10,500. But we would have to calculate how many sweatshirts that is. We know that as the price goes up every 500, we do 100 less. So at $30, we would do 600. At $35, we would do 500. At $40, we would do 400. At $45, we would do 300. So we would get the same profit off of 300 sweatshirts at $45 as we get at 700 sweatshirts at $25. Question 5, what is the domain and range of the function in the context of this problem? This is different. When we've been looking at domain and range up to this point, we've been talking about the function as a whole. So we have to look at the domain and range. We can't say all real numbers for our domain like we normally do because I can't use every X value. I can't sell for a negative price. When we're talking about real life scenarios, we are talking about the first quadrant. So my domain is only going to go from that 10 at 0 over to that 60. This is the domain in context. So my domain can only go from 10 to 60. I can't go below the x-axis in a real life problem. So my domain here (10) is less than or equal to x is less than or equal to 60. So my domain can only go between $10 and $60. And my range for the function, we usually say that the range is just below from the vertex below. But again, I can't go below. So my range is just going to go from 0 up to my profit point of 12,500. So this is my range. Again, in context. We're not talking about the range of the full function. We're talking about the range in context of this specific situation and how we would write that. We would say our range is 0 is less than or equal to y is less than or equal to 12,500. So in context of this problem, that would be my domain and range. It is different than when we talk about domain and range of the function itself, but we have to talk about in context of this problem. Those are the parameters that we can deal with on this. So 6 says, if you had a choice, what price would you set for the sweatshirts and why? What is the whole point of selling the sweatshirts? What are we trying to do? Make as much money as possible. So if I want to make as much money as possible, what price do I need to set for the sweatshirts? Yeah, at 40, I'm already on the downside and I'm making less money. So if I were going to set the price, I would set it at $35 because that would get the greatest profit. So again, we have to think in context of the problem. So dropping dates from a date palm tree. To the right is a picture of a date palm tree. The dates are growing 30 feet above the ground. When a date falls from the tree, its falls can be modeled by the function f of t equals negative 16t squared plus 30, where f of t is the height of the date in feet and t represents the time in seconds. What type of function is this, and how do you know? If you were to graph this function, where would the vertex be and why? Does the vertex represent an absolute maximum or an absolute minimum? How do you know? And will the graph of the function open narrowly or wide? How do you know? Okay, so again, these are the questions we're going to be looking at. This is the function that they're giving us to model this. They're telling us the dates are growing 30 feet above ground before it falls from the tree. So the date is starting at 30 feet. T is representing time that it takes the date to fall in seconds. So they're asking us, the first question is, what type of function is this and how do I know? Sorry, we have a lot of absences today. I'm trying to. Kira, what type of function would be this f of t equals negative 16t squared plus 30, and how do we know it's that type of function? What's the entire title of this unit? So what type of function is that? And how do we know something is a quadratic function? Studied this in Unit 1. The squared. This second power right there is what tells us that this is a quadratic function. And how do we know that it's a quadratic function? The degree of the greatest term is 2. We studied that in Unit 1. We're reinforcing it in Unit 2. So we should know by looking at an equation whether or not it's a quadratic function. We're looking for that highest level of exponent to be a 2, which in this case it is. So this is being modeled by a quadratic function. If we were to graph this function, where would the vertex be and why? Gurpreet, what would be the vertex of this function and why? You can, but just in context of this problem, the vertex is representing either the highest or the lowest point. We're talking about a date is starting in the tree and falling to the ground. What height does the date start at? So at time 0, our date is the vertex would be at 0, 30. The date is growing 30 feet up, and this is where it will fall from. So our vertex, the date can't get any higher than 30 feet. And it doesn't fall up, it falls down. So the highest that our function could be would be 30 feet at time 0, because at time 0, it hasn't fallen from the tree yet. Does the vertex represent an absolute maximum or an absolute minimum, and how do you know? So, Jerry, would this be an absolute maximum or an absolute minimum? So you're saying the vertex would be at the bottom of the graph? Maximum. The date can't get any higher than 30 feet and it's going to fall to the ground. So the vertex will be an absolute maximum. The date will never be higher than 30 feet in the air. All right, so now this is the tougher question. It says, will the graph of the function open narrowly or wide, and how do you know? I'm going to add a question to that. What value in the function f of t equals negative 16t squared plus 30, what value is telling me whether it's going to be wide or narrow? Eric, which number in that function is telling me whether it's going to be wide or narrow? There's only two numbers in the function, so you have a 50-50 chance of the negative 16. The a value is what determines how wide or how narrow. The a value in this case, a is equal to negative 16. So the graph will be narrower because the leading coefficient is greater than 1. The negative tells us it's going to open downward, and the 16 means that the growth is faster. The negative tells us it will open downward. And the 16 means the growth is faster. And that faster growth is what's going to cause it to be narrower. So again, we have to understand the values that are in the function. We have to understand what the function is and what the values, how they impact the function. We need to understand that A value has a couple different things. A determines whether it opens upward or downward, and it also determines how wide or how narrow that function is going to be. Now, the next part says if you have a graphing calculator, but we're not going to use a graphing calculator. We're going to graph it with the chart. You may need a calculator for this part because, again, I'm going to be calling on people to share the values as we create this chart. So if you need a calculator, now would be the time to get that. All right, so Joey, they want to know what f of 0 is. So if I substitute in 0 here, what value do I get? Well, yeah, because what's 0 times anything? And 0 plus 30 would be? All right, for f of 1. Jack, what would I get for f of 1? We would get 14. Anthony, what about f of 2? Negative 2 is not correct. I need to take negative 16 times the quantity 2 squared plus 30. Negative 34. And France, what about if I have f of negative 1? It wouldn't be negative 14 because when I square negative 1, I get positive 1. So it'd be negative 16 times 1 plus 30. So it would give me a positive 14 for f of negative 1. Now, f of negative 1 is part of the function. It wouldn't be part of the context of the problem because the date couldn't start lower, grow up to 30 feet, and then drop down. But let's graph the values we have here. At f of 0, we're up here at 30. At f of 1, pay attention to how your graph is labeled. 1, they're going by halves on the x-axis, so f of 1 at 14. F of 2 at negative 34. And f of negative 1 at 14. So if I draw in that function, that's the values from the chart, so that's what we have. The first question asks us, when will the date hit the ground? Well, I can see that on my graph right here. This is where the date will hit the ground. So Adrian, and I know we have to approximate here because if we had a graphing calculator, we'd be able to tell exactly. But approximately, when will this date hit the ground? 1.5. It's a little less than 1.5. We don't quite go through 1.5. It gets close to that. I will tell you it's closer to about 1.3, between 1.3, 1.4. It actually comes out to 1.37 seconds if we were to graph it on a graphing calculator. But So the date will hit the ground around 1.3 seconds. It says, what are the x-intercepts or zeros of the graph, and what do they mean in the context of this problem? Well, we just said at 1.3 comma 0, and that is the amount of time it takes for the date to hit the ground. And you notice, look at questions 8 and 9 very carefully. 8 says, what is the domain of the and range of the function? 9 says, what is the domain and range of the function in this situation? So we have two different things happening here. The domain and range of the function is just looking at the domain and range of going back to the function f of t equals negative 16t squared plus 30. What did we say is the domain of any quadratic function? So the domain of the function is our all real numbers. Make sure that that r is touching both lines. On the quiz, I would get a line and then an r next to it. The r has to be going through both lines. And what about the range of the function? My y values have to be less than or equal to what? What's the highest y value I have? 30. So y has to be less than or equal to 30. Again, that is the domain and range of the function. In this situation, my domain just is this part here. Because I can't, the date can't go below ground. So this is the domain, which just goes from that 0 to that 1.3. So my domain in this situation is 0 is less than x is less than or equal to 1.3. And what would be my range in this situation? Can my date go into negative feet? No, my date can't go below ground here. So my range would just be this part of the function. Again, for this situation, would be 0 is less than or equal to y is less than or equal to 30. So the domain and range of the function will possibly be different than the domain and range of the situation. We have to make sure that we are doing things in context of the problem.